Hello and welcome to this video where we've come into unsupervised learning. This video will be about k-means, an intuition and theoretical video that you will understand a little bit how k-means work. Then later on we'll go into the code in another video. Without further ado, let's go into the lecture slides. In unsupervised learning, you find groups of similar characteristics and cluster them together. Note that in unsupervised learning, we don't have a label, we don't have supervision. It means that we need to find different characteristics and then we group them together. Okay, let's move on to see what this means. When there is no label, you can cluster the data points. When we're talking about clustering, we're in the unsupervised space. Unsupervised learning, there are no labels. It's more subjective. Annotation of data, it costs money. When people are annotating it, we give them labels manually. It costs money to do that because it costs time. And for larger data sets, that is really costly. What you can do is using unsupervised learning to do clustering, that it becomes grouped together based on different characteristics. Okay, what does that mean? We go into an algorithm called k-means clustering. There are several algorithms for doing unsupervised learning, but k-means clustering is one simple example that I will show you, and it is quite useful as well. But most I show you because it's simple to understand. You can get an intuition of what it means with unsupervised learning. First, you choose k number of clusters, and then k cluster centers get randomized. They randomize somewhere there are a lot of centers, a k number of centers that are randomized around your data. Then the closest points to the centroid is classified as that centroid's class. I'll show you in picture what that means soon. Then afterwards, you compute new cluster center. Then you repeat step 3 to 4 until there's no new class changes. That is basically the idea. What does this mean in picture? Here you can see this is a lot of points, different points. You're supposed to... They have features, 2 different features if we are talking about 2D, but it could be many features. It could be n-dimensional. Now we put out say k equals 3, we put out 3 centroids or 3 center clusters. Say we put out an X and a point and a triangle. These are the 3 clusters that we put out, or these centroids. We say that we start like this. For that, then you take all the closest points, they become classified as... Here, the closest points to X be classified as X. The ones that are closest to triangle becomes triangle. Those closest to point becomes points. Then you have calculated that based on closest distance. Then you use this to calculate new centroids. Here, say that this is the center point for X. This is the center point for triangle. This one is for point. Then, based on this one, these new centroids, we calculate we classify all the points again based on closest distance. And on and forth, we do that until no more changes in classes. Finally, we get something like this, and it becomes classified. It becomes clustered, that those that are most similar are put together, or those that are closest to the centroids are put together. Then we have 3 different classes here. We have done this using unsupervised learning. We didn't need to say that, okay, this class have the label triangle, this class have the label point, etc. We didn't have this information beforehand. Instead, we have just clustered them together. And then we should note that even if we have clustered them together, we don't have a label for that. We don't know still what those means. Then you have human experts or domain experts that can look into this group. For example, if we are doing customer segmentation, then we can see that, oh, the algorithm have chosen a lot of young people in one group. and a lot of older people in another group, then a lot of people within this work discipline, and then a lot of people with this demographics, etc. Then the human experts, they can see that, okay, this group should be called the young group, this group should be the old group, this should be the rich group, the poor, the middle class group, etc. Then you have human in the loop, human afterwards doing the labeling based on the pre-clustered using unsupervised learning. That is very common, that you combine unsupervised learning with supervised learning. Then you have a combine, you give them labels, and then afterwards, based on that, you could do different type of classification, supervised learning if you want. Okay, but the question that arises is that how do we choose k? Because that was a manual part. Here we have chosen k equals 3. Here it says choose k clusters. This is the thing. We don't know how to choose the k. We cannot just say, randomly it's 2 or 3. Maybe it could be like if you have domain experts that say that, we need to have 3 groups here. We need to divide them into 3 groups. Then if they know that in beforehand, then we can choose k equals 3. But in case they don't know that, we can choose k through doing an elbow plot and a silhouette plot. For that, we measure something called SSD. This is the sum of squared distances to the cluster center. You take the distance to the cluster center, you square that one, and you take the sum of all those distances to the cluster center. This is the score that you want to minimize, because if you minimize them, it means that you have very tight clusters. To do that, we do elbow plot. You can try the different k's with, for example, k equals 1, then we have high SD, and then k equals 2, it's a little bit lower, and then 3 is even lower, and then 4 is lower, etc. Then you can see there are a few elbows here that you might be able to pick. Elbows or inflection points, this means that it's when it decreases less. You can see the decrease of the sum of square distances, it decreases less when there's an elbow point. You can combine this with the silhouette plots. And the silhouette plots, it's a measure of tightness of the clusters. You can see here that this is a silhouette plot, and you can see, and then you look for the knee where there's a maximum here. Combine these two with domain expertise to check if it's reasonable, and then you can give different names to the clusters based on what the domain expert says. In this video, we have gone through unsupervised learning in contrast to supervised learning that you've learned before. Here we don't have labels. Instead, we pick the features that are close to each other, and then we do clustering. And clustering algorithm that we showed here was k-means clustering. We chose k number of clusters, and then these were randomized in the beginning, and then afterwards you calculate the closest points. Based on this, we find new clusters, and then we calculate closest points again. This is repeated until no more clusters, no more classes have changed, and then afterwards we discussed how to choose the k through elbow and silhouette plot, and also work together with domain expertise. I hope that you learned a lot from this video, and see you in the next one. Bye!